than maybe you were used to. Like a lot of you, I think we were walking out of here going, wait a minute, I think I got this class. Like, so I just wanted to show you this though. Y'all are familiar with Schoology. Go to Business Calc. Maybe we should change it to a fun picture. I don't know. But I will, in the Business Calc, I'll have folders for each of the weeks. And in yesterday's folder, if you go in, there's a link. It's the actual video of the class. It takes you to a YouTube video. Yeah.
Do I need one of those?
Yeah. I forgot to give you one. I'm sorry. But so the nice thing is, I don't know if y'all not sure if your first language is or is not English, but the nice thing is maybe you've seen this on YouTube and maybe I'm just telling you something that you already have known. But if you went into the video and it takes you to YouTube, this would be the video, but under the closed captioning tab, if you ever wanted to. So it goes English. You know, it works so well the other day. Go into the settings, you can go into the subtitles, and you can go to auto translate, and you can pick me to be any language. So how about, wonder how it looks if we teach it in Danish. So if you go into the thing, it's still English there. So notice the subtitles. It's in Danish. I don't know if anyone speaks Danish in here, but kind of a cool opportunity. So that's just there for you all. Just to know, if you ever miss class and you feel motivated, you can watch a really bad video of the class, but at least stay somewhat caught up. Okay? All right, so I asked you all to have Desmos open on your phone, yes? Was everyone able to get it to work or load it or anything like that? Oh, you did work, so just make sure you have it. And this is like this in my statistics class are the only math classes I've ever known to say, make sure your phones are out on your desk during tests as well, because you'll be using Desmos, which is pretty cool. Will some of you, not in this class, but I know my stats class, there's a couple kids that abuse it, where they'll be like, hey, Billy, what'd you get for number 3? Oh, I got this. So I take the good and the bad, average it all out, and it comes out pretty nice. So we went through a handful of problems. We did problem number 1 as factoring. We did problem number 3 as factoring, and we had done one other, maybe number 7. So we did 1, 3, and 7 on that front page, and we did it on Desmos, and I showed how the factoring worked. Okay, so let's pick number 4, and let's think about what number 4 is. So number 4 is 6x squared minus x minus 2, and we want to factor it. But we're not doing the traditional factoring that you might have seen in Algebra 2 or Algebra 1 or even geometry. We're utilizing the tools that are available for us to show a benefit. So what did I have to do to make this work on Desmos to start factoring it? Yeah, I have to make, if I'm going to jump into Desmos, I'm going to make it y equals. Okay? So that's what I'm going to do. This wasn't showing up. There we go. And our buddy Desmos.com. So problem number 4, once we get into Desmos, and of course on the computer works a little nicer because my thumbs aren't in the way. So I'm going to go y equals 6x squared. So 6x, and I just use the caret. There's also a squared thing. On Desmos, when you go down here, it'll work out nicely for you to do the variables, or if you want to type it, it's up to you. And then just make sure it doesn't stay as an exponent. So you have minus x minus 2. And what was the important thing we looked at on this graph? What did we want this graph to tell us if we were just factoring it? Yeah, I want to figure out where it's crossing the x-axis. So I have here and I have here. Okay? Makes sense so far? And so this is what I'm hoping you're doing on your phone. Unless you're really good at factoring, then please, by all means, do the factoring how you know it. If factoring wasn't your first favorite thing in math, think about doing it this way. It might give you a little bit different opportunity. So I have negative 0.5 and I have negative 0.667. And I think 0.667 should be what fraction? 2/3. And negative 0.5 should be what fraction? Negative 1/2. Okay? So I know that I have 0.5, negative 0.5 comma 0, and I know I have 0.667 comma 0, and those are the zeros. So I'm going to look at the x value. So of course, if I go x equals negative 0.5, I'm going to convert negative 0.5 to negative 1/2, and then I'm going to start solving this. Okay, I don't want my binomial to have a fraction in it, so if I multiply both sides by 2, those cancel. So I get 2x equals negative 1. So 2x, add 1 to both sides to make it equal to 0. That's my first binomial. And then my second binomial, we know that x equals 0.667. We have to realize that if they are rational zeros, that means that they would be able to be written as a fraction. So I have to realize that's the same as 2/3. Multiply both sides by 3 to cancel those. You get 3x is equal to 2. So 3x minus 2. So if I were to put these together, that's the FOIL stuff. Hello. Okay, that's the factored version. And in my opinion, but it's hard to say it in my opinion because I have a degree in math, but I think that if I was sitting in your seats, what I knew when I was in high school, I knew that factoring wasn't my thing to go to. I was good with the factoring as long as I had x squared. You put a number in front of it, I was done. Okay? But having this kind of tool available for you, I think is really, really valuable. Okay? Does this make sense so far? And I want to try, I want to just focus on number 12. Just because number 12 is raised to the 4th power. That's supposed to be an 81 x to the 4th minus 1. Of course, if I want Desmos to work, I need to go y equals. And then again, we're going to utilize the technology for us. So I'm going to go y equals 81x raised to the 4th. Make sure the exponent comes down, minus 1. And this gets a little goofier. Because even if I zoom out on Desmos, it's like, wait a minute, it's not crossing. It's only, it's raised to the 4th power. I remember in my algebra class that if it's raised to the 4th power, we should have 4 solutions to this problem, which is true. But there's times that your solution could be the same thing repeated. Okay? So I'm going to come here, and I'm going to come here. It looks like I get negative 0.3 repeating, and I get 0.3 repeating. And 0.3 repeating would be what fraction do you think? 1/3, yeah. And negative 0.3 repeating is negative 1/3. Okay, so we have to keep in mind, this has to happen to the 4th power. So that means there's 4 binomials that are going to work. And of course, this is difference of 2 squares, so you could identify it as perhaps as, oh, it's going to be 9x squared plus 1, 9x squared minus 1, and then you break down the 9x squared minus 1 and try and fathom it that way. But according to right now, I believe that we might be able to get away with this. Oh, don't do that. Go here. I believe we can say, we know that we have 0.3 repeating, comma 0, and negative 0.3 repeating, comma 0. And what we're going to do is we're going to start realizing, okay, I know that this is x equals 1/3. So that's 3x equals 1. So 3x minus 1. That's definitely a binomial. And then this one is negative 1/3. So that's going to give me 3x minus 1. So that gives me 3x plus 1. Okay, so this is where we kind of have to think, what is really taking place? Okay, remember our graph looks something like this. Agree? Okay, so this is where it needs to take us back. Everyone agree that 1/3 and negative 1/3 are two different numbers. I understand they're the same fraction, but one's positive, one's negative. Okay, so I'm going to take us back to Algebra 2 for a moment. Did you ever hear the term in Algebra 2, bounce, wiggle, cross? You remember hearing that? Okay, so let's go back and take a look at Desmos real quick. Do those look like they have wiggled? No, they're just shooting straight through. A wiggle is going to kind of do a little dance as it goes through. Okay? These are definitely not bouncing. Agree? Okay. So we have a problem here. We have to figure out what we really have to do, because I can tell you that right now, if we were to multiply together 3x plus 1 and 3x minus 1, if I were to FOIL those, you know the four-letter F word math, FOIL? One of these days I'm going to slip and actually say the wrong thing. That would give me 9x squared minus 1. So there's something more that's taken place here that we have to be aware of. We know that as far as the bounce, wiggle, and cross goes, we have 2 times its crossing. There's no wiggles. And a wiggle takes place when you add a binomial raised to the odd power. So 3x minus 1 raised to the third or to the fifth. Okay, we don't want it to the first. First is just going to be a cross. A bounce would be, I would be raising either of these to an even number, so 2, 4, 6, 8. Okay, so that's not taking place. So there's something that's taken place on this problem that's not really working for us to get it completely factored. Okay, so do we have any thoughts of maybe what happened here? And I will tell you, Desmos worked appropriately. But what do you think might have happened? Yeah.
The graph could have gone through the points 0.33 and negative 0.33 twice, because when we multiply these two, we get 9x squared, and that's
Okay.
81x to the fourth. That's like the square root of it.
Okay. Okay. I like your thought. I think that's one idea. Now, I will tell you, I love your idea, but here's where we can debunk it. But I love your idea, so please don't take this as me pushing you away from ever answering again. If that happened twice going through a point, that would have created a bounce on the x-axis. So that would have meant that I would have had this raised to the second power. That creates a bounce, or 3x plus 1 raised to the second. If this was raised to the third, or so if that was the 2, 4, 6, 8, that would have been a bounce. If it was raised to the third, the fifth, or happened 3 times or 5 times or 7 times or whatever, that creates a wiggle. But we definitely have crossings that took place. But I love your thought process. What else might be happening? Do we have any thoughts? Let's go back to the quadratic formula. Remember the stupid song? No, I won't sing it, nor do you have to sing it. And what were some things that the quadratic formula would find us if we couldn't factor it all the way out? What do you think? Well, first off, this part right here, if it's 0, square root of 0 is easy. If it's the square root of a perfect square, that's easy. If it's the square root of something that's not a perfect square, that becomes something called an irrational answer. And irrational answers can't be written as a fraction. But what? Yeah?
There are 2 rational answers in this graph. Is that what it is?
It might be, but in an irrational graph, will cross the x-axis. Okay, so if we look back at Desmos, it is indeed crossing the x-axis.
Is it one of the situations where like you have either an I where you have an I and then you have to do like both of them?
There you go. So you have something called an imaginary root. I, a complex number. Okay, something where the square root, this underneath, is a negative number. So a negative number gives you something called an imaginary number. Okay, which is part of something called the complex number system. Now, I was not involved in the meetings in math to name number systems. Okay, we've dealt with naming number systems pretty much since kindergarten. You remember in kindergarten when you walked in and you were this tall and your teacher was huge and they had above the board, they had 1 apple, 2 trees, 3 carrots, 4, and it was just counting. So they called those the counting numbers. And then as you got to first or second grade, they might have had 0 up there and they said these are now the whole numbers. The whole numbers include 0. Counting numbers start with 1, things you can count. Whole numbers started with 0. So we have whole numbers, counting numbers that you had started with, and you didn't even know this. Then they start getting into things saying, hey, what if we have negatives and positives? What if we have fractions on our number line? What if we have decimals on our number line? So then you start getting into something called the irrational number system or the rational number system. If it's a rational number system, that can include fractions and decimals that will end. If a decimal ends or it terminates, that can be written as a fraction. And then you have the irrational number system, and those are numbers like pi. Remember 3.14159 goes on forever, and yet like a handful of people you've come across that can take pi out to like 1,000 places, and their mind thinks like no one else's. So irrational numbers take place. And then, so of all those number systems, you had the rationals and the irrationals. You had the whole, you had the counting. Those are all part of something that they named it the real number system. And then through Algebra 2 and possibly Algebra 1, you came across the imaginary number system because you could take the square root of a negative number. Okay, and that's where you started putting I in, and I is not a variable. I means it's part of the imaginary number system. A few years ago in Algebra 2, I had a parent call, and I swear it seemed like a comedy act when I was on the phone with the guy. Because we have things called the real number system. We have things called the imaginary number system. Part of the imaginary number system is something called the complex number system. Complex means that you put a real number and an imaginary number together. So that's where you get the 3 plus 2i, things like that. So that becomes a complex number. So the dad calls me and says, Mr. Stirrup. He didn't know he didn't have to call me Mr. He could have just called me Stirrup. He goes, I'm really concerned that you are teaching my child things that are not real. That's right. We're not working with the real number system. Well, what do you mean? How could you have something that's imaginary? Well, that's the square root of a negative number. But imaginary is make-believe. No, it's imaginary. That's the name of the number system. Well, that means it's not real. You're correct. It's not real. It's imaginary. I mean, and I wasn't trying to be a jerk, but I'm sitting there kind of chuckling to myself because I have just enough knowledge to get myself in trouble and not enough knowledge to do anything with it. But it was making me crack up. So what I feel would be taking place on this last problem that's taken place, this and this are definitely 2 of the answers. Okay, so let's write that a little neater. So we have 81 x to the 4th minus 1. I definitely know that 3x plus 1 and 3x minus 1 are part of the answer. But there's something more that has to take place. So we have to maybe see if we can massage into this to figure out what's really taking place. So let's go back to the world of Algebra 1, and they might have given you these types of problems in Algebra 1, and you don't have to write these down because you've probably seen these. And I'm just going to do the first three, where this is x plus 1, x minus 1. And this is x plus 2, x minus 2. And this is x plus 3, x minus 3. Okay? So then we have to think about, okay, what does this factor down to make it look like those? Well, we probably might recognize that 81 is a perfect square because we know that 9 times 9 is 81. Agree? We also should recognize that 1 is a perfect square because 1 times 1 is 1. Difference of two squares, we're being broken apart by a subtraction sign, so difference and subtraction are the same thing. So then we're going to look at this and say, okay, let's take this a little further. If this truly was the difference of two squares, this should factor to this. Okay? And you're like, stir up. That 3x plus 1, 3x minus 1 is not down there on the 9x squared plus 1, 9x squared minus 1. You're right. It's kind of hiding in disguise. What is this right here? Is that still the difference of two squares? 9 times 9 is, or 9 is a perfect square because 3 times 3 is 9. 1's still a perfect square because it's 1 separated. So this is what breaks down to this. These things right here. So the rest of our answer has to be what we can't factor, which is this. So the purple I have up there, I believe it's purplish. Sorry, my eyes aren't as good as they used to be. That's why when I come walking down and my wife says, "You wearing that?" Nope, just trying something. Go back upstairs, try something else. This results in complex answer. Complex answer means that you have an imaginary part to it, so part of the imaginary number system. Okay? Which means if it's part of the complex number system, that means the solution to that does not exist on the x-axis as we know it. Okay? Because right now the x and the y-axis, the horizontal and the vertical, are items that won't cross the x-axis because the x-axis right now as we know it and the y-axis as we know it are both real number system lines. They are not the complex number system lines. We could name the x-axis the complex number line and then we could graph it, but the problem is if we do that, we can't graph the real solutions on the complex number line. So this is the true factored part of it. And that's kind of a tougher part to think about. Okay, so what I want to do, I'm going to give you a little bit of homework. Still with me? I think something that would be fair would be that very first page. It says Algebra Review number 1. And I think if you were to complete 1 through 15 odd, and what I'll do is tomorrow, and I realize I've worked some of those out. Agreed?
Yep.
If you missed yesterday, you can see the other problems worked out on the video. So all I'm looking for on homework is I want an honest attempt by you. And an honest attempt by you isn't, hey, I drew a picture of a cat in a tree in the corner. I want a mathematical honest attempt. The mathematical honest attempt will get you a 4 out of 4 on homework. Okay? Homework will be counted part of your grade. Okay? Tests and quizzes count as another part. Final counts as another part. Okay? I told you not to worry or stress about tests or quizzes in here. Agree? Nobody needs to be losing sleep over business, calculus, tests, or quizzes. Agree? If you're crying yourself to sleep, it's not because of my class. Stop, I cry myself to sleep every night. Okay, it's good for you. Psychologically, it's a really good thing. But I wanted to pause there, stop there. So there.